In the last class, we have read the structures. That means, using structure, how one new data type can be defined. We have also read the what will be the size of a structure, even the for different variable members of the content of the structure, and even for the same number of variables or variable member, same type of variable member, if the ordering is different, ordering of declarations, then the size is actually getting varied. Today we will see mainly we will read the structure pointers, that means the pointer to a structure. But before that, some basics of pointers again we will be reading. So, if you remember that already we have read pointer, very basics of pointer, and that time I mentioned that again some more pointers we will be reading. Okay. We have read normal pointer variable, we have read that pointer to array, how the pointer is passed in a function, all this type of thing we have read. Now again some of the basic things we will recapitulate, and actually we will be reading the pointer to a structure, how we can declare or how we can use in a C program. So pointers in C, we again that if we remember, pointer is again a variable that represents the location. So from the first day onwards, the introductory class I told that whenever we declare a variable, it has two parts. One is it is stored in a memory, it has memory address and the data. So this pointer is nothing but this address, and the data is the pointer is pointing to is the data. So pointer is a variable that represents the location. Location is actually the address rather than the value. Value is the data item. So they have a number of useful applications. Enables us to access a variable that is defined outside the function. So if we remember that swapping of two variables, even that last class when we saw the swapping of two structures, that were not possible by using this simple assignment type of thing in a function. But if we remember, we have done the swapping of two variables using pointer. So this is sometimes we call indirect accessing. So this can be used to pass information back and forth between a function and its reference points. So using pointer, we can actually swap that thing. We read that. More efficient in handling data tables, reduces the length and complexity of a program. So if we learn properly, we will see that our writing C program and the complex program actually will be easier. So basic concept is that in memory, every data item occupies some contiguous memory cells or bytes. This is a byte oriented memory, so bytes. So number of bytes required to store a data item depends on its type, because if it is integer 4 bytes, character 1 byte, float 4 bytes, double 8 bytes, like that. Whenever we declare a variable, the system allocates memory locations for the variable. Whenever we declare. So as already I mentioned, that means these 4 bytes are reserved if I declare it integer type variable. Since every byte in memory has a unique address, this location will also have its own or unique address. So where actually this variable is stored. So that location it will see. So if I declare int xyz equal to 50, that means xyz is of integer type and value is 50. So this has 4 bytes will be reserved against or for xyz. So, this statement instructs the compiler to allocate a location for the integer variable xyz and put the value for this variable as 50 in that location. So, address location, if we think that in the address location 1380, here actually this xyz, it is the reserved, this location is reserved, then xyz is the variable name, variable, 50 is the value what we call data, and 1380 is the address. So, whenever we define int xyz equal to 50 to the compiler, actually it goes like this. These are the 3 documents or 3 information will go, that the xyz is the variable name, 50 is the value, 1380 is the address. So, during execution the system always associates the name xyz with the address 1380. That means, during a program whenever we will be using this variable xyz, it will go to the 1380, that address space, and whatever value is kept there, that it will be taking that thing. Value 50 can be accessed by using either the name xyz or the address 1380, because I can use the address of xyz, actually the value is 50 is kept there, or if I know the value is 1380, suppose we know, then I can use this address because it is same, the address of xyz is 1380. So, since memory addresses are simply numbers, they can be assigned to some variables which can be stored in a memory. So, this is called something called memory variable. That means, this memory address, again this is a number. So, again this can be stored in against a variable. So, such variables hold memory addresses only, and this is called the pointers. So, pointer is also a variable, we call pointer variable. So, this is actually, it contains the memory address like 1380. Okay. I can use the ampersand xyz, because already we know the ampersand is the address, or I can use directly 1380. So, if that means this is a pointer variable. Since a pointer is a variable, its value is also stored in some other memory location. See, xyz is a variable, it is stored in the memory 1380. I am telling 1380 since it is a value, it will be treated as a pointer variable, again variable. So, again this address of this pointer variable, that is also can be stored in another variable. We see that part. See this example. So, suppose we assign the address of xyz to a variable called p. So, earlier example what we see, the variable is xyz, data value is 50, address is 1380. Now, what we tell, the p is set to point to the variable xyz, that means p has the value 1380. So, if p is the variable declared as the pointer, that means pointer to xyz, that means p is the variable which contains the value 1380, and now say this address is 2545, that means another address, that is actually address of p, because p is nothing but a variable, pointer variable. So, how we declare that int xyz equal to 50, all of we know that this we declare as an integer. Now, I define int star p, I define a pointer star p. This is only a pointer I define. Now, unless we give this p equal to ampersand xyz, then there is no relation between point p and xyz. This part we have read earlier, remember that we have done. Then p equal to ampersand xyz means now p is the pointer pointing to the variable xyz. That means p has the same value what the address of xyz is. That means if address of xyz has the value 1380, then once I assign this thing, this assignment statement, p equal to ampersand xyz, then p has the value 1380. P has the value 1380. But if I do not give this the last statement p equal to ampersand xyz, if I do not give this thing, then the previous two is only the two declaration, that one is integer xyz equal to 50, one is a integer pointer declaration instead p. If I give this assignment, then only they have the relation that p points to variable xyz. We have read and we have done small programs also in the lab class. Now, accessing the address of a variable, that is a pointer variable. So, the address of a variable can be determined using the ampersand operator. Normally in the scanf we do. So, the operator ampersand immediately preceding a value returns the address of the variable. So, p equal to ampersand xyz, these will give you the address. So, the address of xyz, what is, for this example we have given one, like say 1380 is assigned to p. The ampersand operator can be used only with a simple variable or an array element. So, ampersand distance, ampersand x0, ampersand xi minus 2, that means one array element. These are all one array element. As if we sometimes we discuss every array element can be as if declared as a separate variable. Just for our ease of representation, ease of accessing, we as if we represent this thing as an array, like xi, I equal to say 0 to 15, then x0, x1, x2, this is as if these are separate variables we have kept together, so that it would be much easier to access, to store, to do some computation with these values. So, these are the ampersand distance means always this will be actually the address of one simple variable or a array element, not the full array. Will come. So, these are all illegal. I cannot give only one ampersand data, no, ampersand variable, normal variable. So, this is illegal, wrong. Int at 20, that means this is one declaration of one array, name is ARR and size 20. Now, that means ARR is the name of a array, full array. So, I cannot give ampersand ARR because that means it is the pointing an array name, no. But if I give ampersand ARR 0, that is correct. That means ARR 0 means the first element of the array. So, address of the first element, that is legal, that is valid. Similarly, ampersand A plus B, pointing and expression, these are all wrong and all illegal expressions or comments. Now, we see this is something, it will clear our concepts regarding the variables, the addresses and the pointers, because that actually we want. So, first we see that one simple example, that one in a main program we define int a, float bc, double d, char ch. That means a is of integer type, b and c two different variables of float type, d is a double type and ch is a character type. Now, we initialize, we give some initial values, a is 10, b is 2.5, c is 12.36, d is 1, 2, 3, 4, 5.66, ch is within first quote we give a because it is a character. Now, we give printf, we print all those variables that just now we have declared and given some initial value. So, we printf %d is stored in location %u. So, a and ampersand a. That means I have read a, and now I try to print a and ampersand a, and I see whether what value I get. Similarly, for each statement we see we have read the B, C, D, E, C, H, and we try to print B ampersand B, C ampersand C, D ampersand D, and CH ampersand CH. See what is the output. So, A is 10. So, the first one is percent D, means the single integer value A is 10 will be printed. So, what it will be written? 10 is stored in location. This is unsigned percent U, and see this is some location. See ampersand, this is the value of ampersand A. This is the value of ampersand A, because I have given A ampersand A. So, 10 is there, A is 10 and 10 is stored in location this. See B ampersand B, next line I have given B ampersand B. So, B is 2.5, B is 2.5. So, 2.5 is stored in location another, some other C location it is given. See what location it is? That it is 4 bytes, 908. It started 3221, 224, 908. These are the examples. And see this 2.5 is stored is 904. That means B, for B 4 bytes are kept. B needs 4 bytes, because B the 908 and that there the next address is 908, there actually it is A is stored. But this can be a different address also, but here it is actually 4 bytes, it is shown that 4 bytes are required. Now, similarly for C, C ampersand C, so C is 12.36, it is stored in this location. See this location address is 900, that means again for C also 4 bytes, C takes 4 bytes, B takes 4 bytes, okay. Then this D is double, D is declared as double, remember for double we need 8 bytes. So, see, so 1, 2, 3, 4.5.6600 is stored in location. See the value of this variable is 92 and this is 900, 892 and 900, that means 8 bytes. See these are 4 bytes, but for D, because D is declared as double, so for D it takes 8 bytes. A is stored in location, this A is a 1 byte, A is, because it is declared as character, CH is a character type. So, A is stored in location 91, 891 and here it is 892. So, actually for it is required 1 byte only. Now, see that it tells that what is actually ampersand A. So, what we have seen, ampersand A is actually nothing but the value of the address, and we see that how actually they are taking the how many bytes for different data types, different variables of different data type. Now, we define pointers or declare. The pointer variables must be declared before we use them. So, general form is data type star pointer name, we read earlier, remember, and this star, this tells that this is a pointer variable, pointer name is a pointer variable. Pointer name needs a memory location and pointer name points to a variable of type data type. That means pointer name points to a variable of type that data type, that means that it points to the variable that same data type the pointer variable must have. We give example, the int star count, that means count is a pointer variable name of the pointer variable. Float speed, that means the count will point to a variable of type integer, speed will point to a variable of type float. Once a pointer variable has been declared, it can be made to point to a variable using an assignment. Already we read, unless we give the assignment statement, pointer will not be pointed, there is no relation. So, int star p x y z, this is just we have declared one p is a pointer variable we have declared x y z as a integer variable. We give p equal to ampersand x y z, that means p is pointing to x y z since both have the integer type. So, it is a match, it is called a pointer initialization. So, this is pointer initialization. We read all those things. See here float x and int star p. So, if I give p equal to ampersand x, this is a wrong thing, it is a mistake because the data types are different. So, that means pointer, it points to a variable, that data type of the variable and data type of the pointer must be the same, otherwise it will be error. This is a erroneous output. So, assigning a variable through its pointer. So, once a pointer has been assigned the address value of the variable accessed using the indirect operation. That means int a b, two integers a b integers, int star p. So, three variables pointer variable. P is ampersand a, that means p points to a variable a. So, what is the value of a? P has the same value, star p has the same value. P is ampersand a means address of a is the p. That means, if I get the star p, the pointer, that means pointer has the value same as that of what is a. Now, if I write b equal to star p, that means what the value, because star p has the same value as that of a and so b has the same value. So, it means it is equivalent to b equal to a. See, this is a indirect thing we have done, indirectly assigned. That means a has the value and p is pointing to that address of a. So, that means pointer p pointer has the value of a. Now, I am giving b equal to star p, the pointer. So, the b is actually already p is getting the value of a. So, that star p, that value is assigned to b. So, b equal to a. We have read earlier also this thing, two different way I can access. One directly I can give, because a, b and c equal to 5 and one p pointer. So, a equal to 4 plus c plus 5, c equal to 5. So, it will be giving you the 5 plus 5 10 40, because I can do now I can assign p equal to ampersand c. That means p is ampersand c means p is pointing to the variable c. That means star p has the same value as that of 5. So, now if I give this assignment statement b equal to 4 star p plus 5. So, star p is also 5. So, it will be the same value. So, that is why it is 2 equivalent. A is 40, b is 40. This b and a, and these are actually equivalent. That means, two different ways we are accessing the value here and computing a. C actually we are accessing and using pointer or directly. This example we read earlier. Now, we see the how it is stored or what actually is giving. So, int x y, two integer variables x y and one ptr, that means one star ptr is the one pointer ptr, ptr is one pointer variable. We give x equal to 10, that means this is the initial value x equal to 10. Ptr equal to ampersand x, that means ptr is pointing to x, that means star ptr has the same value 10, remember with this assignment. Y equal to star ptr, that means y equal to also 10, just now the previous thing also we have done the same thing, okay, c and b. So, these are also same value. Now, printf this d first x ampersand x. So, what will be x ampersand x? X is 10 and the address of x. So, x is 10, 10 is the stored in location say some 908, that means 322122, last 3 digits I am telling 908, it is 908, it is stored. Now, next line I am printing star ampersand x ampersand x. So, ampersand x is what? Is the address of x, and star ampersand x is means that what is stored in ampersand x, what is stored in ampersand x? The value of x. So, it is again it should be 10 and this is ampersand x means the address, these two are same. So, again these two ampersand x ampersand, this is the address of x and see this is also 10. So, I have written x and I have written star ampersand x. This is actually the indirect accessing, as if I am giving the address x and in that address what value is stored, that means it is x value, that we are telling the same. Now, we are giving star PTR and PTR. What is star PTR? Star PTR is y and PTR is ampersand, PTR is ampersand x, that means star PTR is 10 only. See, star PTR is third line, star PTR is 10 only. It is location is PTR. So, it is again the, because PTR is nothing but ampersand x. So, these are all ampersand x because PTR is ampersand x. So, it is stored, 10 is stored in location. Then the fourth line, the y is an ampersand star PTR. Y is already we have seen y star PTR. So, PTR is the same ampersand x. So, y is also 10. And what is ampersand star PTR? Because star PTR is the value of x, this is x, ampersand x, again this is ampersand x. So, again 10 is stored in location. See, then see the first 4 printf statements. I am giving x ampersand x, star ampersand x ampersand x, star PTR PTR, y ampersand star PTR, all are actually same value it is showing. That means the 10, x equal to 10 and the address of x. This is nothing but once directly we are taking the x value, one is through the pointer, one is through the y, the value y, because y is also assigned as the pointer value. Next, fourth printf statement, it is PTR and ampersand PTR. PTR and ampersand PTR. Now, what is PTR? See, the assignment statement, PTR is ampersand x. What is ampersand x? It is the address. What is ampersand x? It is the address. So, PTR, PTR and ampersand PTR is ampersand x. So, this is the address and ampersand PTR. So, ampersand PTR is the address of PTR. So, see, this is ampersand x. So, this is ampersand x, that means address of x is stored in, see, another value, because this is address of PTR. So, this is another location where actually, because PTR is also a pointer variable. So, this is here. Now, the last printf statement, y and ampersand y. Why is y? Y is 10 simply. Last we have seen, because y is star PTR. So, y is 10 and ampersand y is address of y. So, this is 10 and see, this is a different location. This is actually when the variable y is declared int xy. So, that time the address of y. So, it is the address of y. So, simply this is y is the value is 10, but the address is different because y. So, now star PTR equal to 25. Now, what we are giving, that star PTR equal to 25. Now, star PTR is that PTR is a pointer variable and star PTR is the value that it is pointing to. So, that value equal to, now I am giving assigning 25 to that value. What is star PTR? See, star PTR is actually PTR is pointing to x, PTR equal to ampersand x. So, actually x must be 25 now. So, we check printf x equal to, see, I have given star PTR equal to 25, I have not changed x, I have not done here x, but actually indirectly using the pointer I have changed the value of x, and now if I print, we will see that x equal to 25, x equal to actually printed 25. See, here I have not used x, but indirectly the using pointer I have meant, because ptr is a pointer pointing to x, because a ptr is the address of x. That means ptr is pointing to the value of x. What I have done, that using the pointer, the point ptr is pointing to that star ptr, I have assigned 25. So, that means my x value has become the 25. And here actually what the assumption we have done for the address of the x, y and ptr, that it is given that address of x is this 908 that we have used, address of y is 404, address of ptr we have taken as the 000. So, I think it is clear. We have read also that mainly the pointer means this is the address of the variable that particular pointer is pointing to. Now, some pointer expressions. We have not read this part earlier. So, we can do some arithmetic operations using the pointer variables, using pointer. Like other variables, pointer variables can be used in expressions. Means arithmetic expressions we can use. Say P1 and P2 are two pointers. Then the following statements are all correct statements, valid statements. Sum equal to star P1 plus star P2. Why it is valid? Because just now what we have read, that star P1 is a pointer variable, that star P1 is a pointer. If we declare P1, P2 are two pointers, then star P1 has the value of the same variable that P1 is pointing to. That means star P1 has some value. Similarly, star P2 has the value of that variable where the P2 is pointing to. So, these are some value. It can be integer, it can be float, whatever value it is. So, then I get, if I get two values, then that can be added, and that I keep at the sum. So, only this data type should be same, that we can do. Similarly, prod equal to star P1 star P2, because once I know that star P1 is a value, some arithmetic value, so we can multiply. Or star P1 we can give parenthesis also, because star P1, because same, these are nothing but only the if there is some confusion with this star and this star, but actually this is our operator, the multiplicative operator, and star P1 or star P2, this represents a pointer. So, same star P1, this thing we can multiply. Star P1 equal to star P1 plus 2. See, these are some variable. Is it the thing that always 2 will be added? No. This is the star, it can, the star P1 has the some value that it is getting from the, that the variable it is pointing to, 2 will be added there, 2 is added there. X equal to star P1 divided by star P2 plus 5. Again we can divide also, because since star P1, star P2, these are the some we have some arithmetic value, we can divide, and the division will be division will be done depending on the data type. Remember, if it is integer, so different type of thing, if it is a float, different, whatever the value I will get, arithmetic value, 5 will be added with that thing. Now, here what is written, that see, it is that star P1 we can appear on the left hand side also, because I can assign some value, that means, it means the star P1 is star P1 plus 2, means always it will increment the variable by 2, the value of the variable by 2, which variable? The P1 is pointing to. P1 is pointing to that variable, that value will be always incremented by 2, that if I give this type of the star P1 equal to star P1 plus 2. So, we can do the addition, multiplication, division, we can do this type of arithmetic operation with pointer expressions. Now, add an integer to a pointer, subtract an integer from a pointer, subtract one pointer from another. So, here we can use subtraction also, addition if we can do. Now, see, only we can do this subtract one pointer from another, we can do this thing only for subtraction is allowed for this type of thing. See, these are two different. Here we have done star P1, star P1, star P2, these are actually some value, the value of the variable it is pointing to. But P1, P2 are the pointer itself, P1, P2 is the pointer itself, and we know what is P1, P2 if the pointer is nothing but the value of the address. So, if I give P2 minus P1 or P1 minus P2, it gives the number of elements between P1 and P2. Number of elements between P1 and P2, because P1 and P2 are both pointers to the same array. Same array means the data types are same. That means we know that how many bytes are required for each array element. So, each array element how many bytes are required. See, if it is of integer, then 4 bytes are required for this. If I do P2 minus P1, then the number of bytes, the divided by 4, it will be giving that value. That means that will be the how many numbers, it will give the number of elements between P1 and P2. So, the difference means how many, these are the things. Okay. So, only subtraction of integer, a subtraction of one pointer from another, that is only, it has some meaning, it has some meaning that we can do. So, you say it is, that's why it is called a related type of thing, because it is same type. If P1, P2 are of different type, then it is of no meaning. Okay. Now, add two pointers, no, allowed, because it is not a meaning, because P1 is of some address and P2 has some different address, P1, P2 is address, and then P1 equal to P1 plus P2, it is of no meaning, that same this address is again I am adding the address cannot be the adding at the same address I cannot get. Similarly, multiply and divide, because P1 is P2 by 5, no, that one address cannot be there, this type of integer division not possible. P1 equal to P1 minus P2 start 10, this P1 minus P2 is valid, but I cannot multiply this thing by 10. So, this mainly addition, division, multiplication of pointers have no meaning, only we can do the subtraction if they are of same data type. So, normally we use for the array, because the array elements are of same data type. So, this is a very important thing is called the scale factor. So, we have seen that an integer value can be added or subtracted from a pointer variable. So, int star P1 star P2, int ij, int star P1 star P2, that means two pointers we have declared, two integer variables we have declared, all are integer type. Then P1 equal to P1 plus 1, that means P1 we know that one address. Now, if we add 1 here, it is allowed. Please see, here I told P1 equal to P1 plus P2 is not allowed, but here I tell P1 equal to P1 plus 1, that means some integer value, it is allowed. So, why this is it the thing that 1 will be added? No, this will be the if my P1 is of integer type, that means for P1 I need 4 bytes. So, this 1 means here actually 4 bytes will be added, and this is called the actually scale factor. So, P1 equal to P1 plus 1, P2 equal to P1 plus j or P2 plus plus, P2 equal to P2 minus I plus j. See, all are integers because ij are integers. These are all valid. In reality, it is not the integer value which is added or subtracted. That means this 1, I am adding 1, but it is not actually 1. Rather, the scale factor times the value. So, scale factor means that actually that how many bytes it is required, because it is the address, and address means always the address is actually byte oriented, memory is byte oriented. So, address of each byte is given. So, that is why it is given. So, character it is 1, int it is 4, float it is 4 bytes, double is 8 bytes. So, if P1 is an integer pointer, then P1 plus plus means 4 bytes will be added. So, it will increment the value P1 by 4. So, earlier slides, what is P1 plus 1? That means 4 bytes will be added. So, P1 plus j, that means 4 into j bytes, 4 j bytes, it will be added 4j, because j means that for each one it is a 4 bytes, for j bytes it will be 4 j bytes. So, P1 plus 4j. Okay. So, it will be added. So, that means that pointer can be added by integer values. Okay. And this integer is not the integer, actually that is a scale factor. It depends on the data type. For particular data type, what are the actually number of bytes. So, it will be added 1 means actually it will be 4 bytes will be added, or 4 j bytes will be added, like that. Now, the exact scale factor may vary from one machine to another. Repeatedly we tell, because it depends on the compiler, can be found out using size of function. So, size of data type we can, it will give how many data types, what will be the, how many bytes will be required. So, to find the scale factor, see some in a main program, if you do in this way, say number of bytes occupied by int is size of int, size of float, size of double, then if you give, then immediately you will be getting that if it is 4481, it will be giving like that. So, you can find out that what will be the scale factor, or how many bytes are actually required for the integer, float and character types. Actually, we have already read, other than these printing this value of some variable and the address, and the printing the pointer variable and the address of the pointer, or the value or the variable it is pointing to, that we have seen the what is the difference, or how actually we can print the values by printing. Actually, by printing we have seen what are the differences, and how we can access in different way, indirect accessing or direct accessing. Now, pointers and arrays, this part also I have mentioned, but I told that again with some complex problem we will be reading. So, the basic pointers and array that we have read. So, the compiler, when an array is declared, compiler allocates a base address and sufficient amount of storage to contain all the elements of the array in a contiguous memory location. This is very important, that contiguous memory location means successive memory locations. If it is an integer array, then for each array element 4 bytes, 4 bytes, 4 bytes, like this. If the array is of size 10, then 40 bytes together will be reserved. And the base address is the address of the first element of the array, that means index 0. If A is the address, then A0, that means the first element. So, address of the first element is the actually base address or the address of the array. The compiler also defines the array name as a constant pointer to the first element. We have learned this thing. That means, if I declare a pointer pointing to the array, that means the pointer has the same address as that of the base address. That means, pointer has the same address, the address of the first element of the array. we have read, remember these slides I have shown and we have read this thing, again we repeat, revising, we have giving a revision, so that we will go to the actually we will be reading the structure. So, the declaration int x5 one array, x is an integer array and it has 5 values 1, 2, 3, 4, 5. So, suppose that the base address of x is 2500 and each integer requires 4 bytes. So, x0 is 250, x0 is 1, the first element of the array. What is the address? I told that it is 2500. So, I have written 2500. Then x1 is 2, the value is 2 and since it takes 4 bytes, so it will be 2504, address will be 2504. x2 will be 3, x3 will be 4, x4 equal to 5 and C again it will be taking 00 and each 4 bytes extra because it takes 4 bytes and since they are contiguous means successive. So, now it is 2500, 2504, 2508, 2508, then 2512, then 2516 like that. We know this thing, in this way it will be declared. Now, both x and ampersand x0 have the value 2500 because x is the array. So, if I tell the x and ampersand x0 is the same, that means address of x and address of the first element of the array same 2500. So, p equal to x and p equal to ampersand x0 are equivalent. Okay. That means p equal to the base address of the array, p equal to the address of the first element. Repeatedly we told and we have learned this portion. We can access successive value of x by using p or p minus minus, because just now we have seen that pointer we can decrement or we can increment or we can decrement, because p means p plus 1 and 1 means actually one scale factor. Scale factor is that how many bytes that particular data is kept in the array, 4 bytes, then it will be advancing in 4 bytes, or if p minus minus, so it will be reducing by 4 bytes. So, relationship between p and x. So, if p equal to ampersand x0 is 2500, then p plus 1, or I can write p plus 1 is ampersand x1, p plus 2 ampersand x2, p plus 3 is ampersand x3, p plus 4 is ampersand x4, and already we have seen the ampersand x1 means the next the second element which is address is 2504, third element address is 2508, 2512, fourth element 2516, and star p plus I gives the value of xi. Star p plus I gives the value of xi because this is star p plus I means this is a pointer that it is ith the pointer goes to the after ith element of the array. Okay, then it will be star p plus I gives the value of xi. Okay, star p plus I also will be the same. Okay, star p plus I will be also the same because like p plus 1, star p plus I is the p plus I is the p plus I is the like p plus 4 is the fourth element of the address, p plus I will be the ith element of the address. So, this is ampersand xi, then star ampersand xi is the value of xi. So, that is the value of xi. Okay. So, this is similarly only in general it is written like that. Now, function to find average, and we have seen that part, we read, if you remember this function we have done the average, this main program we have one average function and this is star p. So, star p plus I we have done just now. What we have done actually, we I equal to 0. So, we are advancing, but we are with pointer, not the directly element wise. Okay. Now, we come to with these basic concepts of pointers. Now, we read the pointers and structures, because this part actually last 2 days we are actually reading the structures, last 2 classes. Now, how actually the pointer points to the structures, that we will be reading that part. So, structure revisited again. Stud is the structure, then it has 3 variable member, role, department code and CGPA. And struct stud ABC means ABC are 3 structures having the same type, is the stud type. That means ABC have all A dot role, A dot department code, A dot CGPA, like the same thing. So, and the individual structure elements are like this. That C dot CGPA, that means C is a stud type of structure, and it has, so it is a new data type, that stud type of structure, it has the elements. Now, we can define an array of structures. This also we have read, that instead of class 1, class 2, class 3, like we can give class 100. That means each class I actually of type stud. That means is class I dot role, class 20 dot department code, class K plus plus dot CGPA, like this thing we have. It is already we have read. Now, pointers and structures. So, you may recall that the name of an array stands for the address of 0th element. Many times, whenever the array we read, I always mention the address of the array is the address of the first element of the array. Again, it is written like that. Address of the first element is the 0th element. So, also true for the names of arrays of structure variables. So, this is true for arrays of structures also. So, consider the declaration. Again, this is a stud type of structure, role, department code and float CGPA. An array is a class 100 and star PTR, one pointer. Now, see what we have read, that class 100 is actual type structure stud, that means class I dot role, class I dot department code, like that. I define a pointer star PTR, that again this is of structure stud, that means PTR is a pointer that is pointing to a structure of this type. PTR is a pointer that it is pointing also that it has also that role, department code, CGPA, there are 3 variable name. Now, how we can access using pointer, because for normal variables or array variables, what we have seen, that how that indirectly using the pointer we can access the values of the variables or values of the each array element. Now, the name class represents the address of the 0th element of the structure array. PTR is a pointer to data objects of the type struct stud, as I mentioned already. So, assignment PTR equal to class. See, unless we do this assignment, there is no relation, because it is only similar. Earlier also I told that we can always define a pointer, but unless we give the assignment, then there is no relation that this pointer is pointing to this variable. Similarly, here PTR is a PTR pointing to a structure of type stud. Class 100, all that class I, it is of actually the same type of stud type of structure, it has 3 variables. So, unless I give PTR equal to class, this assignment, we do not have any relation. So, here we will assign the address of class 0, because now class is a, now see this array of structures, this is an array of structures. So, class 0 is the address address of class 0 to PTR. Now, we are assigning that thing. The PTR equal to class means again the address of the first element, and the PTR is assigned. When the pointer PTR is incremented by 1, PTR plus plus, the value of PTR is actually increased by size of stud. So, now we know that what will be the size of a structure. The last class we have read that size of structure, that actually not the direct sum of the bytes of the variables, member variables, it is actually after padding that we have read. So, the size of stud we have read, what is that many number of bytes it will be increasing, because that is the scale factor. For structure, that this is now the scale factor. So, PTR plus plus means that actually next structure it will be going, and what will be the thing, that this what will be the size of, that means how many bytes are required for this stud structure. That padding is again we have to consider, that means again order of declaration of this role, department code and CGPA will be coming into picture, and then that size will be given. It is made to point to the next record. That means if that the class 0, then it will be class 1, like that. It will be going like that. How we will access using pointer? So, once PTR points to a structure variable, the members can be accessed as PTR arrow role, PTR arrow department code, PTR arrow CGPA. The symbol is called arrow operator. Remember, earlier not using a pointer, just a variable, when structure variable we have done like A1, then we have given A1 dot role, A1 dot department code we could give. Like class, here we have given, I can give class I dot role, class 5 dot department code. But here when it is a pointer, then this is the syntax, that PTR arrow role, PTR arrow department code. So, PTR role and star PTR dot role mean the same thing, because PTR arrow role this is, and star PTR is the like, because now it is a pointer, star PTR is the PTR is pointing to some array element, array, because array of structures. So, each of structure type, that element is of structure. So, that dot role, that means if it is a pointing to say class 5, then class 5 dot role. So, it is PTR arrow role and star PTR dot role has the same meaning. Okay. So, warning, when using structure pointers, we should take care of operator precedence. This is very important. Listen, that member operator dot has higher precedence than star. Dot has higher precedence than star. So, PTR arrow role and star PTR dot role mean the same thing. So, but if I do not give the parenthesis here, this bracket, if we do not give, you give star PTR dot role, what will be it will mean? It will mean as if PTR dot role is a pointer type, it will lead to error, because since dot has the higher precedence. So, that means that I must give this, unless I give this parenthesis, star PTR will not be treated as a separate thing, because star PTR is a pointer pointing to. So, if I now give star PTR dot role, as if it thinks that PTR dot role is a pointer type, but it is of no meaning, because I have not declared any pointer like that. So, it is a wrong. Similarly, the operator arrow enjoys the highest priority among operators. Okay. So, plus PTR role, that means since it has the highest priority. So, PTR arrow role, it will be incremented once. So, it is correct, we will increment role, not PTR, because this is has the highest precedence. So, it will be first increment PTR roll, it will get the PTR star PTR dot roll, and then plus plus, that means it will be incrementing that value. But here if I give plus plus PTR roll, that means what it will be meaning, that plus plus PTR means it will go to the, will do the intended, it will do the intended thing, means it will go to plus plus PTR, means it will be incrementing PTR and then get the roll. So, see, the two things are different. Here we will increment the roll, not PTR. What we want here, we increment the roll number, but not PTR, because PTR roll, what the roll I am getting plus plus, it will give some value, no wrong things, but what I actually am getting, I am not incrementing PTR, I am incrementing the roll number I get by through PTR. And here actually I am incrementing the PTR plus PTR arrow roll. That means here first I increment the pointer and then I am accessing the roll. So, these are the different things. So, you must remember this thing. Now, if we do the complex number addition, already we have seen the how complex number is defined, and then these are the ABC of 3 structures we have defined, complex of type complex data type. So, A dot real, A dot imaginary, B dot real, B dot imaginary, and C. Already we have seen this function and we have added C, A, B and kept the result to C. Now, this is complex X, complex Y, we have seen that C return T. So, it will be giving you the sum. Now, using pointer, what we can do? The main program, similarly we are reading the values of real and imaginary parts of A and B. Now, see the function we are writing, the void add complex star X, complex star Y and complex star T. That means, now we have to use the, since they are all pointers. So, these are actually TRE, that means the T, since T is a pointer. So, T arrow the real part and T arrow the imaginary part, it will be the X, because these are X and Y are pointer. So, X arrow RE, Y arrow RE, X arrow IM, Y arrow IM. That means, if we use the arrow for accessing the variable member, value of variable member, then I have to use the arrow, otherwise we have to use the dot, what earlier structures we have done. Okay. So, with this, the how the pointers to structures are defined, and we can access the value of member variables or the structures. I can access the one structure using a pointer, that part we have seen. Okay. So, we finish the lecture of structures and pointer to structures.